Yes, next we will discuss about different operators that are used in C language. Okay, so first here, operators in C. Okay, so there are different types of operators starting from arithmetic operators. Okay, and second one is relational operators. Third one is logical operators. Fourth one is assignment operators. And next, fifth one is increment decrement operators. Okay. And next, sixth one is ternary operator or conditional operator. Ternary operator or conditional operator. And next, seventh one is comma operator. And eighth one is size of operator. And ninth one is bitwise operators. Okay. So these are the different types of operators that we are going to discuss now. Okay. So out of all, first I'll discuss assignment operators because for any operation we require assignment. Yes or no? So equal to operator is generally used in any expression. Okay. First I'll discuss assignment operator and then we'll go in the sequence, that is arithmetic, relational, logical, like this. Okay. So first, starting with assignment operator. So what is the corresponding operator used for assignment operation? So you can see equal to is the corresponding operator which is used for assignment operation. Okay. So what is the general syntax of using this assignment operator? Okay. So the general syntax for using assignment operator is clearly variable equal to expression. So this is the syntax of assignment operator. Okay. So you can see equal to operator. Okay. So what is the functionality of this? Is that first the expression on the right hand side will be evaluated and the result will be copied into the variable. Okay. So let me consider an example for this purpose. Consider A is equal to 2 into 3. Okay, star is the operator used for multiplication. Okay, so 2 into 3 means value is 6. So value of 6 will be stored in a variable A. Okay, you can see A value is now 6. Clear? Like this. Now I'll show you another example where equal to operator or assignment operator is used multiple times in a single expression. So one is assigning multiple variables corresponding value at the same time. Okay, so for example, consider like this: A is equal to B is equal to C is equal to D is equal to 100. Okay, and before that you can actually declare all these variables int A comma B comma C comma D. So what is the purpose of this expression and declaration? You can see it is going to declare A, B, C, D are integer variables. Okay. So this is going to allocate memory for A, B, C, D variables. Yes or no? So A, B, C, and D. Just like this. So the moment you are using A equal to B equal to C equal to D equal to 100, you can see first D value becomes 100. Okay, so value of D is 100 now, and then D value is copied into C, so its value will become 100. Next, value of C is copied into variable B, so B value will also become 100, and then value of B is copied into variable A, and A value will also become 100. Like this, you can see all variables corresponding values are assigned to 100 at the same time. Okay, so this is the purpose of using assignment operator. Okay, and now we'll discuss the next operator, which is arithmetic operator. Okay, so what are different arithmetic operators here? So in arithmetic operators, we have these operators: plus, minus, star, slash, mod. Okay, so what is plus signifying? Plus represents addition operation. Okay, so plus is representing addition. And next, minus is representing subtraction operation. And next, star is representing multiplication operation. And a slash is representing the division operation. And mod is representing, this percentage is representing modulus operation. Okay, like this. So now we'll see each of these operators in detail here. So first one is addition operation. So how we can write addition operation in the program? Okay, so first of all, we can declare the header file like this: hash include stdio.h. Okay, and in the main program or main function, first declare any two variables like int a is equal to 10 and then b is equal to 20 and next c. Okay, so c is equal to a plus b. C is equal to a plus b. Okay, and we are trying to print value of c. C is equal to percentage d and printing the c value. So this is how we can make use of addition operation in the program. Okay, so what happens exactly is a is equal to 10 and b is equal to 20. So first two variables are allocated. A value is 10 and it is going to allocate another variable. B value is 20. Now c is another variable. Okay, so c is equal to a plus b. You can see immediately writing c is equal to a plus b is nothing but c is equal to a value is how much? 10 and b value is 20. So which is nothing but 30. Yes or no? So finally this c value holds value of 30 after performing the addition operation like this. Okay. And finally in the output we are going to display c value. C is equal to 30 like this. Okay. So this is how we can perform addition operation. Okay. Next, consider for subtraction operation and multiplication operation. Okay, simultaneously. So let's consider like this. Include the corresponding header file. Now, in the main function, take any two variables like int a is equal to 10 and b is equal to 3, c comma d. Okay, so in order to illustrate subtraction operation, I am considering c is equal to a minus b semicolon. So in order to represent multiplication operation, I am considering d is equal to a into b. Okay, so finally we can print these results like c is equal to percentage d slash n c value. Similarly, we can print d value as well. Printf d is equal to percentage d slash n d value. Okay, just like this. So what happens exactly while working with this code is that, first of all, see here a is equal to 10 and b is equal to 3. Okay, so it is going to allocate memory for these variables. A value will become 10 and b value is 3. Okay, and now you can see c is equal to a minus b. So c is equal to a minus b, which means value of c is equal to a minus b. This is evaluated like this. C is equal to 10 minus 3, value is 7. Okay, so value of 7 will be stored in a variable called c. And then d is equal to a into b. So here d is equal to, what is value of a? 10 and value of b is 3. 10 into 3 is 30. So variable d is now holding value of 30 here. Okay, and finally in the output you can see it is going to display the result. Okay, C is equal to, what is the value of C here? 7, and D is equal to 30. Okay, so this is how we can make use of subtraction operation and multiplication operation in the arithmetic operators. Okay, so now we'll see an example for division operation. We'll see an example for division operation. So hash include in the main function. We are going to take two variables. Let us suppose int a is equal to 1 and b is equal to 3. Okay, and I'm taking another integer variable called c. So c is equal to a divided by b. Okay, and what is the corresponding output displayed by this particular program? Okay, we are printing c value, right? So then you need to find what is the output for this particular program. Okay, so remember the output for this program will be 0. Okay, the output printed by this program is 0. Why? Because this is going to consider a is equal to 1 and b is equal to 3. It is creating two memory locations, one for a and holding a value of 1, and another memory location for b and it is holding a value of 3. Okay, now writing into c will be another memory location. Okay, initially holding a garbage value, and c is equal to a divided by b. The moment you write c is equal to 1 divided by 3, this is considering an integer division. Okay, it is performing integer division. So when it performs integer division, value produced will be in the integer. Okay, so if you observe the exact floating point value that is produced by this is 0.33333 like this, but since it is performing integer division, only this part will be displayed, which is nothing but 0. Okay, so we are printing value of c 0. Now how to modify this code such that it is going to display floating point value, that is exact value 0.3333 like this. For that purpose, in the same program, if you are taking floating point variables like this, float a comma b, and similarly here also float, and while printing floating point value, you have to take percentage f instead of percentage d. Yes or no? Like this. So next one is modulus operation. Okay, so how this modulus operator is going to work? Modulus operator always gives you the reminder. Okay, so for example, a is equal to 1 and b is equal to 5. Okay, and we are performing c is equal to a mod b. Okay, then what will be the c value? C value produced will be 1. Why? Because you can see this expression getting evaluated 1 mod 5. Okay, so this is of the form x mod y, where x value is less than y. In that case, result will be x only. Okay, when you're performing x mod y, if the value of x is less than y, in that case directly you write x as the result. Okay, so now we'll take another example. Consider a is equal to 5 and b is equal to 2. C is a variable. C is equal to A mod B. We are performing. Then what will be the result produced by C? C holds A mod B value, which is 1. Why C is equal to A mod B is producing 1 here? You can see clearly. First, you take C is equal to 5 mod 2. This is nothing but dividing 5 with 2. Okay. And what is the corresponding remainder obtained here? 5 is divided with 2. So 2 times value produced will be 4. Hence the remainder is 1. So this is the corresponding output produced here. Clear? Okay, like this. Now I'll write a program, find the output for this particular program. Okay. So here inside the main function, I'm considering int a is equal to 10. Okay. And float b is equal to 3. Okay. And also c. So c is equal to a mod b. Finally, I am printing value of c here. Printf percentage f c. So what will be the value produced as the output for this particular program? Can you guess? Okay. So clearly you can see a mod b. Okay. This particular program is going to produce an error. This is going to produce an error. Why? Because in C language, this modulus operator is defined over integer operands only. Okay. So remember operand 1 modulus operand 2. Okay. So let's see what is the result obtained when you take operand as integer, when you take operand as floating point type. Okay. Result. So when you consider operand 1 as integer and operand 2 as integer data type, you will get the result. Okay. Result is obtained. But if you look at the other cases like an operand is integer, operand 1 is integer and operand 2 is floating point type, in that case it is going to produce an error. Okay. If you consider another case like operand 1 is floating point type and operand 2 is integer data type, in that case also it is going to produce an error. If you consider another case where both these operands are floating point type, operand 1 is floating point type and operand 2 is floating point type, in that case also it is going to produce an error. Okay, just like this. So always remember when you are applying modulus operation between operands, both these operands must be integer, then only you can get a result. If any of the operand or both the operands are floating point type, in that case it is going to produce an error. Okay, like this. So now I'll consider a program here. int a is equal to 3, and we can consider int b. So b is equal to minus a, and when you print value of b as output, so which is percentage d b value, in that case it is going to produce the output as minus 3. B value produced is minus 3. Okay, so always remember this plus operator and minus operator in arithmetic operators are acting as both unary operator as well as binary operators. Okay, so both are unary and binary as well. Okay, so in order to give an example for unary operation, you can see a is equal to plus b. This is an example. Okay, the same value of b, which is positive value, is copied into a. Next, similarly, a is equal to minus b. Then minus is multiplied with b, and that value will be copied into variable a. This is for unary operation. And if you are considering binary operation, the expression examples are a is equal to b plus c is one example. Okay, and a is equal to b minus c is another example, illustrating both addition and subtraction operations. Okay, like this. So this is how it is going to work. Whereas operators like multiplication, division, and modulus operators are strictly binary operators. Okay, in case of arithmetic operators. Okay, like this. So we are done with the arithmetic operators, and now we'll discuss about relational operators in C. Okay, so if you observe relational operators, what are different relational operators in C? Okay, and remember, all these relational operators are clearly binary operators. Okay, you require two operands in order to apply this operation between, right? So these are the different operators like less than or equal to, greater than or equal to, not equal to, like this. Okay, so now if you observe this, less than, this is the meaning of less than. Okay, so less than operator, and meaning of this is less than or equal to, less than or equal to. And next, this is a symbol of greater than, greater than. Okay, and next this is symbol of greater than or equal to, or equal to. The next one is equal to. Okay, so you can see this is a symbol of equal to. And next one is not equal to. This is not equal to, like this. These are different relational operators. Okay, so let's discuss about these relational operators. Okay, consider int a is equal to 10 and b is equal to 2. Okay, so we can write this inside the main function. Okay, just like you can consider using these statements inside the main function. Suppose if I write a print statement like printf percentage d a less than b. So what is the result that is going to be printed here? Okay, so always remember here a less than b is evaluated like this: 10 less than 2. Condition true or false? 10 less than 2 is evaluated as false. Condition is false. Since condition is false, it is going to produce value as 0. The corresponding value produced is 0, just like this. Now, let's write a small program which makes use of all these operators. So always remember, whenever the condition is evaluated to true, it is going to return a value of 1. Okay. If the condition is false, it is going to give you a value of 0. Okay. So consider this program. So inside the main function, I'm considering two different variables like int a is equal to 5 and b is equal to 3. And let's see if we write like this: printf percentage d a less than b. Okay. And similarly printf percentage d a less than or equal to b. Okay. Next printf percentage d a greater than b, and printf percentage d a greater than or equal to b. Next similarly printf percentage d a double equal to b, and printf percentage d a not equal to b. So this is the entire program, and let's see each of these condition how they are going to work. Okay, so first of all value of a is equal to 5 and value of b is 3. Okay, so writing a less than b is nothing but 5 less than 3. This particular condition is evaluated to false. Okay, so when the condition is false, immediately this is going to produce an output of 0. Yes or no? 0 is the corresponding output produced for this particular line. Okay. And next, similarly, a less than or equal to b, 5 less than or equal to 3. Condition true or false? 5 less than or equal to 3. Condition is false. So when the condition is false, it is going to produce 0. Next, a greater than b, 5 is greater than 3. Condition is true. So this is going to return 1. Okay. And next, a greater than or equal to b, 5 greater than or equal to 3. So condition is true. 5 greater than or equal to 3, condition true. And next, a double equal to b, 5 double equal to 3. Condition is true or false? Condition is false. So this is going to produce value as 0. And then a not equal to b, 5 not equal to 3. Condition is true clearly. Okay. So this is going to produce value as 1. Yes or no? Like this, it is going to produce the result. Okay. And this is the working of relational operators in C. Now, next one is logical operators. Okay. So here in logical operators, we have three types of operators here. Okay. One is logical AND operator. And second one is logical OR operator. And third one is logical NOT operator. Okay. So these are the types of logical operators available in C. Okay. So what is meant by logical AND operator? Remember, both these logical AND and logical OR operators are binary operators to the conditional expression. These two are binary operators, whereas logical NOT is a unary operator. Okay. So if you are considering logical NOT, which is unary operator, it means it is not going to be applicable between the conditional expressions. Instead, it is applied to a single conditional expression. Whereas if you consider binary operators, logical AND and logical OR, they are applied between two conditional expressions. Okay. So I'll show you an example for binary and unary difference. So A greater than B, logical AND A greater than C. So this is how we apply logical AND. Here we are considering A greater than B as conditional expression 1 and A greater than C as conditional expression 2. Okay. Now, if you consider logical NOT operator, so this is not of A greater than B. Okay. This is only one conditional expression if you observe. Okay. And NOT is a unary operator, so it is applicable to only one conditional expression. Okay. So this is how generally we apply logical operators, and we will see the functionality of logical AND first of all. So to understand logical AND operator, first of all, what are the possibilities of conditional expressions evaluation? Every conditional expression can be either true or false. Yes or no? Now this is applicable between two conditional expressions, which means 2 power 2 is equal to 4 possibilities we will get. Okay. So you can see here conditional expression 1 and conditional expression 2. And we are applying between two conditional expressions like this. Conditional expression 1, logical AND conditional expression 2. So when we are applying between two conditional expressions, the possibilities are like this: true, 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 false, false, true, and false, false. Okay. So what is the result obtained here? So remember, for logical AND operator, whenever both the conditional expressions are evaluated to true, then only the result will be true. Otherwise, the result is going to be false. So true logical and true is true. And true logical and anything is false. Okay, just like this. False logical and false is false. So this is how we can apply logical AND operation between the conditional expressions. Okay. So let us consider an example to understand this. int a is equal to 10, b is equal to 5, c is equal to 7. Okay, so here if I write conditional expression as like this, consider an if statement containing like this: a greater than b logical and a greater than c. Okay, then some action is defined in the code, let us suppose. So what is the corresponding action? These things we will explore once we enter into if block, if else block, everything. First focus on this conditional expression. A greater than b, this is evaluated like this: 10 greater than 5, condition true or false, this is going to produce condition evaluation as true. And then a greater than c, a greater than c is 10 greater than 7, condition is true, this condition is true. Now you can see conditional expression 1 and conditional expression 2, logical and, when both are true, it is going to produce the result as true. So true means it is going to consider value as 1. Okay, if one associated block of statement gets executed. Okay, so let me write an example related to logical and operation here. Okay, in the main function we are considering variables like this: int a is equal to 10, b is equal to 3, c is equal to 1. Okay, now I'm writing a printf statement here. Printf percentage d, suppose b greater than c logical and b greater than a. So what will be the output produced by this particular code? What is the corresponding output produced by this code? So this type of aptitude questions will be asked in the interviews. So let's evaluate how this is going to produce the output. Okay, first of all, b greater than c, you can see this is evaluated as 3 greater than 1, and then write down logical and. B greater than a, that is 3 greater than 10. Okay, so what is 3 greater than 1 and what is 3 greater than 10? Okay, 3 greater than 1 is evaluated to true and 3 greater than 10 is evaluated to false. If you look at the table, true, logical and false. Okay, true, logical and false is going to evaluate false, and false is represented by 0. Okay, so this is going to produce the output as 0, just like this. Okay, so next one is logical or operator. Okay, logical or, this is represented like this. Okay, so in the logical or operator, remember this is also a binary operator. Okay, so it means it is applicable between the two conditional expressions, like conditional expression 1 we have to consider, conditional expression 2 we have to consider, and this logical or operator is applicable between two operands like this. So conditional expression 1 logical or conditional expression 2. Okay, so if you consider conditional expression 1 evaluated to true, true, or possibilities true, false, false, true, and you can see here false, false. These are the four possibilities. 2 power 2 is equal to 4 possibilities. So when you apply logical OR between these conditional expressions, okay, so if any one of the conditional expression is true, then the result will be true. Okay. So when both the conditional expressions are false, it is going to produce the result as false. So true logical or true is true. True logical or false is true. False logical or true is true. False logical or false is false. Okay, clear. So like this. Now we will consider an example for logical OR operator. Okay. Consider int a is equal to 1, b is equal to 2, and c is equal to 3. Okay. So there is a condition written here. If a less than b logical or c less than b, then perform some action. Okay. So if this is the case, how this is going to be evaluated? So you can observe first conditional expression is a less than b. So this is nothing but 1 less than 2. Okay. Logical OR. And what about this? C less than b. That is 3 less than 2. 3 less than 2. So 1 is less than 2. Condition is evaluated to true. And 3 is less than 2. Condition is evaluated to false. You can observe true, logical, or false. True, logical, or false is evaluated to true. Okay. True, logical, or false is evaluated to true. So according to the table, you can see true, logical, or false is true. It means the conditional expression is evaluated to true. So the associated block of statements will be executed here. Okay. So now let's say consider an example related to logical OR operator with the help of a program. So first include header file stdio.h. Okay. And in the main function, we are going to consider three variables similar to the previous one. A is equal to 10, B is equal to 4, C is equal to 6. Okay. So here we are writing a printf statement. Printf percentage %d. Okay. A less than B logical or B less than C. Okay. And another one is printf percentage %d A greater than B logical or B greater than C. Okay, like this. So what will be the corresponding result for this particular program? And the output will be written here. Okay, so let's see the evaluation. A value is 10, B value is 4, and C value is 6. Now if you observe the evaluation of this condition, A less than B logical or B less than C. Okay, so which is nothing but here A less than B logical or B less than C. Okay, so 10 less than 4 logical or B less than C, 4 less than 6. So 10 less than 4 condition is false. Okay, and 4 less than 6 condition is true. False, logical, or true is evaluated to true. So this is going to be evaluated to true. So when it becomes true, it is going to produce the output as 1. Yes or no? True is represented by 1. Next, similarly, we will consider for the next printf statement, a greater than b, logical or b greater than c. Okay, so a greater than b is 10 greater than 4, logical or, and then b greater than c, 4 greater than 6. So you can observe 10 greater than 4, condition is true. Logical or 4 greater than 6, condition is false. True, logical or false is evaluated to true, isn't it? So again, true is represented by 1. This is going to produce 1 as output. So 1, 1, both the conditional expressions are evaluated to true. Okay, so the corresponding output will be 1, 1. Okay, like this. So now coming to the next operator in logical operators, which is logical not operator. So logical not operator is represented like this, and in this logical not operator, always remember this is a unary operator. It means there are only two possibilities. One is true, the other one is false. So consider the conditional expression, okay, and perform the not operation on this conditional expression. So true, false, there are two possibilities. Not of true will be false and not of false will be true, like this. Okay, so using this we will write a small example here. The example is in the main function I'm writing int a is equal to 5 and b is equal to 5. Okay, so here printf %d not of a double equal to b. Okay, similarly printf %d not of a not equal to b. So let's see how this is going to produce the result. Okay, in this we have already considered a equal to 5 and b is equal to 5. So what is not of a double equal to b? Okay, and you can observe not of a value is 5 double equal to 5. Okay, so what is 5 double equal to 5? Condition true or false? Condition is true. So we can say not of true. Not of true is evaluated as false. Okay, applying not operation to true is producing a result as false. Okay, like this. So false is represented by 0. Okay, so it is going to produce result as 0 for this particular printf statement. Okay, now let's evaluate this printf statement. Not of a not equal to b. So this is not of 5 not equal to 5. So 5 not equal to 5, condition becomes false, and there is a not operator in front of it. Not of false is going to evaluate as true. True is represented as 1. Okay, so this is going to produce 1, 0, 1. Clear? Like this. So these are all about logical operators in C. Okay, so next, coming to the next operators here. which is increment decrement operators in C. Okay, so now let's discuss this increment decrement operators in C. Okay, first we will discuss about increment operator. Again, in this increment operator we have one is pre-increment and the other one is post increment. Pre-increment and post increment. Okay, so both these pre-increment and post increment are basically used with the help of plus plus operator. Okay, suppose you consider variable as a. Pre-increment means it is represented as plus plus a. Post increment means a plus plus. Okay, so individually when you are applying on a single variable, you don't find much difference for the pre-increment and post increment. Okay, so but when you are using it as part of the expression, you will find a huge difference. Okay, so let's discuss with a small example. Okay, yeah, for pre-increment. Okay, so consider like this, int a is equal to 10. Okay, then plus plus a, and later I am printing value of a here, percentage d a value. Okay, so then what is its corresponding result that is going to be displayed here? Okay, so first of all, the moment you execute this line, okay, a value is 10. Variable a stores value of 10, and then next plus plus a. So this is evaluated as a is equal to a plus 1. A is equal to a plus 1, which is nothing but value of a is 10. 10 plus 1, so a value will be 11. So current value of a is updated to 11. And when you start printing value of a, you can observe the output as 11. Okay, output produced is 11. So now you can see here, next one is post increment. Similarly, if you observe in post increment operation, how we can write this post increment operation? Okay, so for post incrementation we can write, let us suppose int x is equal to 5. Okay, and here we are performing post incrementation as x plus plus, then printing value of x. Okay, printf percentage d x value. Then what is its corresponding output that is displayed here? And you can see here clearly int x equal to 5, which means x is a variable whose value is 5. Okay, and next x plus plus. What is x plus plus? X plus plus is evaluated as x equal to x plus 1. Okay, which means x equal to 5 plus 1. X value will become 6. Okay, so the current value of x is modified from 5 to 6 after performing post increment. So finally the output when you are printing value of x, x value will be 6. So when you are applying on a single variable, okay, which is not as part of the expression, then you don't find any difference between pre-increment and post-increment. Yes or no? So if you observe pre-increment, here also when I take value of a as 10, when you perform pre-increment, value is incremented by 1. So similarly, post increment, I have taken initial value of x as 5 and just incremented it by 1. So finally the value got incremented by 1 only. Okay. So there is no difference when you are performing individually. So now let's use this pre-increment and post-increment operations as part of the expression. Okay. So let's see how we can make use of this as part of the expression. Okay. So let me consider this particular program here. So in the main function, I'm considering variables like this. Int a is equal to 5. Okay. B is equal to 5. A is equal to 5 and B is equal to 5. We are considering C comma D, another two variables. Okay. So here I'll use C is equal to plus A. Okay. And D is equal to B plus plus. D is equal to B plus plus. Finally, we are going to print value of C and D. Okay. And also A and B. Clear? So let's first print value of A and B. Okay. A is equal to B is equal to, so you can see A comma B. Okay. And then printing value of C and D. C is equal to percentage D. D is equal to percentage D. C comma D. Okay. So you can use slash n here. Okay. Let's see the working of this particular program. And in this example, you can clearly see the difference between post increment and pre increment when you're applying this as part of the expression. Okay. So let's see here. C is equal to plus A. Okay. This is going to be evaluated like this. First, A is equal to A plus 1 is performed, and then C is equal to A is performed. This is the respective action. Okay. So let's see what is the result obtained here. The moment we are performing A is equal to A plus 1, value of A is 5, 5 plus 1, and A value will become 6. Now again you can see C is equal to A. C is equal to A value is 6. Okay, like this. Now similarly you can see D is equal to B plus plus. Okay. So this is evaluated like this. First D is equal to B is performed, and then B is equal to B plus 1 is performed. Okay. So when you perform this action like this, D is equal to B. What is B value? 5. And then B is equal to B plus 1. B is equal to 5 plus 1. Value will be how much? 6. So finally, in the output, it is going to display A value and B value. So what is A value here? The updated value of A is 6 and the updated value of B is, okay, how much? B value is updated to 6. So now coming to C value. What is the C value? C value becomes 6 and D value will become 5. Okay. So that is the difference between pre-increment and post-increment. So in the pre-increment, first the increment operation is performed and then the result is copied into the variable which is lying on the left hand side. Whereas if you consider post-increment, first the value is getting copied into the LHS variable and later this increment operation is carrying out. Okay. So this is the basic difference between pre-increment and post-increment operations. Okay. Now coming to the decrement operators, so similar to increment operators, we have decrement operators as well. So again in this decrement operator, this is denoted by minus minus, similar to incrementation. In the incrementation we have plus plus. Since it is decrementation we have minus minus. So in the decrementation operation we have again two types. One is pre-decrement, the other one is post-decrement. One is pre-decrement, the other one is post-decrement. Okay, so again you can see pre-decrement represented like this, and so like for example A. Okay, so pre-decrement, if you are applying a decrement operation on a variable, you can see this is written like this, minus minus A. Okay, post decrement example, A minus minus. Okay, so when you're applying both individually, you can see both are performing the same action. Okay, so when you're writing A minus minus semicolon or writing minus minus A semicolon, so both are going to give you the result as A is equal to A minus 1. And this is also going to produce the result as A is equal to A minus 1. Okay. But when you are applying as part of the expression, the results will change. Okay. So consider an example like this. Int A is equal to 5, comma B, comma C. Okay. So let us suppose first you are performing B is equal to minus minus A. Okay. And then performing C is equal to A minus minus. Okay. So finally, what are the results that are obtained? What will be the value of A finally? What is the value of B finally? And what is the value of C finally? Okay. So let's see this code. A is equal to 5, right? Now execution of this particular statement, B is equal to minus minus A. So this can be evaluated like this. B is equal to minus minus A can be evaluated as, first it is going to perform the decrement operation. That is A is equal to A minus 1. And then B is equal to A. Yes or no? First the decrement operation is performed and then the value will be stored into variable B. Okay. So writing A is equal to A minus 1. A is equal to, value of A is 5. 5 minus 1, value will become 4. So next B is equal to A. B will hold value of A which is 4. Okay. So now similarly consider C is equal to A minus minus. How this C is equal to A minus minus is evaluated? First, C value will become A value, okay, and then A value will be decremented by 1. So C is equal to A means C value will become whatever value of A is latest. 4 is the latest value of A. And then A is equal to A minus 1. A value is 4. 4 minus 1 value will become 3. Okay. So if you observe the final values of A, B, C, and you can see A value is 4. Okay. Current value, latest value of A is clearly 3. And B, what is the latest value of B? B value is 4. B is equal to 4. And then latest value of C is 4. Clear? This is how the updation operations are performed. Okay. In case of increment, decrement operators. Okay. So let's consider a program which makes use of both increment operators and decrement operators. Okay. Now consider A is equal to 5, okay, comma B, comma C is equal to 3, comma D. Okay. So here B is equal to minus minus A, okay, and D is equal to C plus plus, okay, and then again B is equal to minus, okay, D minus minus, D minus minus, and then finally A is equal to minus minus B, okay. So finally we are printing value of A, B, C, D. A is equal to percentage D slash T, and then again B is equal to percentage D slash T, C is equal to percentage D slash T, and D is equal to percentage D slash N. So you can observe A comma B comma C comma D. All values of A, B, C, D are getting printed here. So let's see what are the values that are going to be displayed in this case. Okay, first of all, you can see A is equal to 5. Okay, and B is equal to minus minus A. So B is equal to minus minus A is evaluated as first A is equal to A minus 1 is performed, and then B is equal to A is executed. Okay. So when you write A is equal to A minus 1, 5 minus 1 value will be 4. Okay. And then you can see B is equal to A. B value will also become A value, which is 4. Okay. Clear? Like this. Now, after this, the next statement to be executed is D is equal to C plus plus. Okay. First, D is equal to C will be executed, and then C is equal to C plus 1 will be evaluated. Okay. So let's see what it is going to produce here. D is equal to C. What is the latest value of C here? C is not yet updated, so value will be 3. Then C is equal to C plus 1. 3 plus 1, value of C will become 4. Okay. Now coming to B is equal to D minus minus. First D value will be stored in a variable called B, and then decrementation operation is performed. D equal to D minus 1 is performed. Okay. So writing B is equal to D means B value will hold value of D. So you can see current value of D is 3. So 3 will be stored here. And then D is equal to D minus 1. D value is 3. 3 minus 1 value will become 2. Okay. And finally you can see A is equal to minus minus B. So this is going to be evaluated as b is equal to b minus 1 first, and then a is equal to b will be evaluated. Okay. So what is b is equal to b minus 1? You can see the latest value of b is clearly 3. So 3 minus 1, b value will become 2 here, and a is equal to b, the same value is copied into a. So finally you can see the output as value of a. Okay, so value of a is clearly 2, and what is value of b? B latest value is 2. Okay, and what is value of c? C latest value is 4, and what is value of d? You can see d latest value is 2. Okay, like this. So this is the corresponding output that is produced by this particular program. Okay. Okay. Next one is ternary operator in C. Okay. So we'll discuss about this ternary operator. So this ternary operator is also known as conditional operator. Okay. So this ternary operator or conditional operator is acting as a replacement for the if-else block. Acting as a replacement for if-else block. Okay. So the general syntax for this ternary operator is that we can write like this: variable is equal to expression1 question mark expression2 colon expression3 semicolon, like this. Okay. So according to this ternary operator, you can see when the expression1 is evaluated, suppose if this expression1 is evaluated to true, okay, it is evaluated to true, in that case expression2 will be evaluated and the result will be copied into variable called var. Okay, suppose if this expression1 is evaluated to false, okay, in that case you can see expression3 will be evaluated and its corresponding result will be copied into a variable called var. Okay, so why this is a replacement of if-else statement? Okay, so consider an example for if-else statement like int a is equal to 10 and b is equal to 4 comma max. Okay, so when we write if-else statement, this can be written as if a greater than b, max is equal to a, else max is equal to b. Okay, so now the same functionality can also be achieved with the help of conditional operator or ternary operator. Okay, so if you clearly observe this functionality, first it is checking the conditional expression, yes or no, a greater than b question mark. Okay, it is checking the conditional expression. If it is evaluated to true, in that case it is storing max equal to a, simply storing max equal to a. And if this conditional expression is evaluated to false, in that case the max value is modified to b, max is equal to b is executed. Okay, so this is the functionality of if else statement in the given code fragment. Okay, so now the same can be written with the help of ternary operator. How this can be achieved is using ternary operator. You can write max is equal to, first one is expression one same question mark, right? So what is expression one question mark? A greater than B question mark. So when this conditional expression is evaluated to true, then A will be copied into max, otherwise B will be copied into max. Yes or no? So here you can see clearly A greater than B. Okay. The same values 10 greater than 4. Condition true or false? Condition is true. In that case, value of A is copied into max. So max value now will become 4. Yes or no? Just like here also, you can see the conditional expression 10 is greater than 4. Condition is evaluated to true here. So max value will be A. Now the updated value of max is 10 here. Okay. And here also you can see max value is basically 10 because 10 greater than 4 and value of A is 10. Okay, and value of B is 4 here. So A value getting copied and you can see value of A is 10. So 10 will be copied into max. Okay, like this. So we can write a sample logic in order to find similarly maximum among three given numbers. Okay. So I'll tell you the easiest logic in order to identify the maximum among three given numbers. Okay. Finding maximum among three numbers. Okay. So first include the header file hash include associated stdio.h. So in the main function, okay, so I'll consider three variables like int a is equal to 10, b is equal to 5, and c is equal to 15. Finally, you need to find a maximum value among three given numbers, right? So I'll consider two more variables. One is temp, the other one is max. So first I will find a maximum among two numbers. Then that value I will compare with the third value and finds the maximum among those two numbers. So how this can be done? You can use ternary operator. Temp is equal to A greater than B question mark A colon B semicolon. Now similarly for max, in order to find max, you compare temp with the third variable which is C. So temp greater than C question mark. In that case, you can copy temp, otherwise C can be copied into variable called max. And finally, you can print value of max here. Maximum value is equal to percentage D max. Okay, like this. Okay, so let's see how this is going to work here. A is equal to 10. It is going to create memory location A, B, and C. B value is 5 and C value is 15, like this. Okay. So next one is execution of this statement. Temp equal to A greater than B question mark A colon B. Okay. So this is executed like this. Temp is equal to what is A greater than B? 10 greater than 5 question mark. Okay. 10 colon 5 semicolon, like this. Okay. So you can see 10 is greater than 5. Condition true or false? Condition true. Okay. So when the condition is true, immediately this value will be copied into temp. Okay. So you can observe the current value of temp is 10. We are able to find the maximum among two values first. Now I'll compare this maximum value with the third number, so that again I will identify the maximum among those two numbers. So finally we are able to get maximum among three given numbers. Okay. So let's see the execution for this particular statement. Okay. Max equal to temp greater than C. So just look at this. Max equal to what is the value of temp? Temp value is 10 here. 10 greater than C. 10 greater than 15 question mark. Temp colon C. So temp value is 10 colon C. C value is how much? 15. Okay. So 10 greater than 15, condition true or false? 10 greater than 15, condition will become false. When the condition is false, this particular value will be copied into max. So finally you can observe the max value will hold 15. And finally this is going to print maximum value is equal to 15. Okay. So among the three numbers, A equal to 10, B equal to 5, and C equal to 15, which is a maximum value? 15 is a maximum value, isn't it? So finally that is going to print. Okay. So this is how we can make use of ternary operator. Okay. So let's see and check how a given number is even or odd. Okay. How we can check the number is even or odd with the help of ternary operator. Okay. So we are checking even or odd. Okay. Even or odd using ternary operator. Okay. So in order to check the number is even or odd, we can make use of modulus operator. Yes or no? If any number is divisible by 2, okay, which means if it is trying to produce the remainder as 0, in that case we can say it is a even number. If it is producing a number as 1, for example, so after division it is producing 1, you can see this is clearly an odd number. Okay. So very simple here. The logic is like this. First of all, you consider number as n. N is equal to 5. Okay. So what is 5 mod 2? 5 mod 2 is 0 or 1? 1. It means 5 is a odd number. Suppose if you are taking n is equal to 4, then what is 4 mod 2? When you're dividing 4 with 2, remainder will be 0. So when you're getting remainder as 0, it is obviously a even number. So 4 is a even number. Yes or no? Like this. Okay. So let's write this particular code. Okay. So in the main function, let us suppose I'm taking a variable n is equal to 5. N is equal to 5. Now we can write this ternary operator, or we can use this ternary operator like this, n mod 2, okay, double equal to 0, question mark. So when this happens, when the condition is true, in that case you can print it is even. Okay, so we can write here it as printf even. Okay, and then colon, after colon we can write printf odd. Okay, like this. So how this is going to work here is that first of all we are checking n mod 2 double equal to 0 or not. Okay, double equal to 0. So if the condition is true, in that case we are printing the number is even number. Okay, so we are displaying it as even. If the condition is evaluated to false, in that case we are displaying it as odd number. Okay, n mod 2 double equal to 0, condition is true, then even number. If it is false, it is going to display odd number. So now you can see here n mod 2 double equal to 0, that is 5 mod 2 double equal to 0, condition true or false, condition false, so it will go into this and it is going to print odd. So finally you can observe the output is displayed as odd. Okay, just like this. And next, coming to this next operator, it is comma operator. Okay, so next one is comma operator. So example usage of comma operator, you can observe whenever we are declaring multiple variables, we are using comma operators to separate them. Yes or no? So for example, I want to declare multiple variables like A, B, C, D. Then I can write like this: A, comma, B, comma, C, comma, D. Okay. So writing this is equivalent to writing int A semicolon, int B semicolon, int C semicolon, int D semicolon. Okay. So instead of writing 4 statements, we can write a single statement with the help of a comma operator. Yes or no? So this is one advantage. And not only in the declaration part, okay, even small expressions you can separate with a comma instead of writing directly the semicolon. Okay, so let's see that particular example. We know int, okay, suppose I want to perform swapping operation, 10 comma b is equal to 25 comma temp. Okay, so if you remember the code for swapping that we have done today, temp is equal to A is equal to B is equal to temp, using the third variable or temporary variable in order to perform swapping. So instead of writing 3 lines here, we can also optimize this particular code and make use of comma operator and write the entire thing in a single line. So like temp equal to A, comma, A is equal to B, comma, B is equal to temp. Okay, just like this. So with a single line, you can perform the entire task with the help of comma operator. Okay. And next, this comma operator will also be used as part of scanf statement. So what is meant by scanf statement? Scanf statement is used to read values at runtime. So till now, I have directly initialized the value of a variable at compile time. Even the compiler knows what I'm actually initializing. So using scanf statement, we can also read values at runtime. So I'll show you with an example. Suppose printf, okay. So I'm considering int n, okay. Printf enter any value, okay. So using this, you can see here clearly scanf statement can be written like this: scanf percentage d address of n, okay. So when you are entering any value, now you're trying to access the address of the variable and store the value into variable called n, okay. Suppose if you want to make use of multiple variables to read at runtime, you can make use of scanf statement and also comma operator, okay. So in comma operator, you can see here clearly, I want to read multiple values like a comma b comma c, okay. So enter any 3 values is the corresponding printf statement, isn't it? So we will prompt the user to enter any 3 values. So in order to read 3 values into variables a, b, c, we can make use of scanf statement, that is a scanf percentage d, decimal integer values, percentage d, percentage d, percentage d, okay. Address of a comma address of b comma address of c. So if you want to read individually, then we have to write 3 scanf statements. Instead of writing 3 scanf statements, we can write a single statement and read all these values of a and b and c, okay. You can say address of a, address of b, address of c, everything is separated with the help of a comma operator. Even after performing an action on these variables a, b, c, if you're trying to print value of a, b, c, you don't need 3 different printf statements. You can also print in a single statement with the help of comma operator again, okay. How this can be done, you can see in printf. So you can write like this: printf percentage d percentage d percentage d a comma b comma c, okay. You can print values of a, b, c like this. So now next one is you can see comma operators is done, and the next one is size of operator. Okay, so let's discuss about this size of operator. This size of operator is going to return number of bytes that are allocated for a particular variable or data type. Okay, so let's see an example here. Int a is equal to 5. Okay, now we can print a size of integer by writing directly percentage %d size of int. This will give you size of integer data type, and also we can write printf percentage %d size of a, size of a. Okay, so both are going to produce the same value because a is also integer data type, and the output will be exactly the size of integer. Okay, so it can be 2 bytes or 4 bytes based on the size of the word in the system. Okay, because integer data type occupies equal to the size of the word. Okay, so in the same way you can write or declare multiple variables and display their corresponding sizes, which I'm going to show you. Okay, like this. Yeah, here now consider character data type. Char ch is equal to y, for example, and float f is equal to 1.396. Okay, and double d is equal to 4.35 4.25578. Okay, now we can display the size of these variables or size of these data types. Okay, so if you write here printf percentage %d size of ch. Similarly, printf percentage %d, here I'll use /t size of f, and then similarly printf percentage %d/t size of d. Okay, just like this. Now you can observe here char ch is equal to y, which means character data type ch is holding a character like small y. And next it is creating a floating point memory location which is capable of holding 1.396000 like this. And similarly, it is creating a double data type variable which is going to store as 4.2557800 and so on like this. So now the moment it is asking size of ch, how much is the size occupied by the character data type? The moment you are asking size of ch, it is nothing but size of char, which is nothing but 1 byte. So in the output, it is going to display 1. Okay. Next, what is the size of floating point type? Size of f, floating point type is going to occupy 4 bytes. So it is going to display 4. And next, what is the size of d, which is a double data type? So the size occupied by the double data type is 8 bytes. So it is going to display the result as 8. Okay. So size of operator is always used to display the size occupied by the data type or a variable under a data type. Clear? Like this. So next one is bitwise operators. So let's discuss about bitwise operators in C. Okay. In bitwise operators, we have different types of operators like bitwise AND operator, bitwise OR operator, bitwise exclusive OR operator, bitwise NOT operator, bitwise left shift operation, and bitwise right shift operation. Okay. So first one is bitwise AND operator. For representing bitwise AND operation, we use this operator. Next, similarly, bitwise OR operator is denoted like this. And bitwise XOR, bitwise XOR operator. Next, bitwise NOT operator, represented like this. And there are shift operators in bitwise. So there are two types. One is left shift operator. The other one is right shift operator. So left shift operator is indicated like this, and the right shift operator is indicated like this. Okay. So now coming to this first type of operator, which is bitwise AND operator, let's see this bitwise AND operation. Okay. So bitwise AND operator is represented like this. Okay. So every bit can be either 0 or 1. Okay. And when you apply this bitwise AND operation, which is a binary operation, okay, it's not a unary operator, it is a binary operator. Okay. So if you consider bit 1, okay, and bit 2, so let us suppose you are performing a bitwise AND operation between both these bits, bit 1 and bit 2. Okay. So the possibilities are, you can see 0 0, 0 1, 1 0, 1 1. So 1 bitwise and 1 is going to give you the result as 1. In all other cases, result will be 0. Okay. So 1, and you can see in all other cases the result is 0. Why? Because this is bitwise AND operation. When both are true, then only the result will be true when you apply AND operation. In the same way here also, true is represented as 1 and false is represented as 0. So when both are true or when both are 1, then only the corresponding result will be 1. Okay. So now let us consider an example for performing AND operation, bitwise AND operation here. Okay. Consider A is equal to 3 and B is equal to 5. Okay. And compute A and B. So let us suppose C is equal to A and B. Okay. Then what is the value of C? You can consider A is equal to 3 represented as 8421. Okay. So this is represented as 0011. Okay. And next B is represented by 5. 5 is represented like this 101. Okay. And operation A and B. Okay. So you can observe 1 and 1 is going to give you the result as 1. 1 and 0 is 0. 0 and 1 is 0. 0 and 0 is 0. So A and B is represented as 0001, which means the value of C will become 1. Yes or no? Because according to 8421 code representation, only here 1 is there, which means the answer is 1. Okay, like this. Now we'll write a program related to bitwise AND operator. Okay, first include the header file, and in the main function you can consider two variables just like this. A is equal to 6 and B is equal to 8. Okay, and you're performing C is equal to A and B. So finally we are printing a result after performing bitwise AND operation. Okay, so C is equal to percentage D, like this. Okay, so the moment we write C is equal to A and B, okay, what is value of A here? A value is 6. A value is 6. How we can represent A equal to 6 in 8421 code representation? 8421 representation. This is 0110. Next, value of B is 8. So how we can represent value of B? Okay, is 1000. Okay, so this is A value and this is B value. Now C is nothing but A and B. Okay, 0 and 0 will be 0, 1 and 0 will be 0, 1 and 0 will be 0, 0 and 1 will be 0. So finally you can see C value will become 0. Okay, and in the output you are printing value of C. So value of C is 0, just like this. Okay, so now next one is bitwise OR operator. So let's discuss about bitwise OR operator. So what do you mean by bitwise OR operator? Whenever both the bits are zeros, okay, then only you will get result as 0. In all other cases, you will get result as 1. Clear? So you can see bit 1, bit 2, and we are performing OR operation between both the bits, bit 1 or bit 2. Okay. So the possibilities are 0, 0, 0, 1, 1, 0, 1, 1. So only when both the bits are zeros, then only you will get result as 0 when you apply OR operator. In all other cases, you will get 1. It means at least if one bit is evaluated to 1 or both the bits are evaluated to 1, the result will be 1. Yes or no? So let's consider an example related to bitwise OR operator. Consider variable a is equal to 2 and variable b is equal to 3. Okay. And c is equal to a or b operation we are performing. So let's see how this is going to be evaluated. Okay. So value of a is 2. So 8421 representation. In order to represent 2, you can write like this 0, 0, 1, 0. In order to represent b, whose value is 3, you can represent like this 0, 0, 1, 1. Okay. Now c is equal to a XOR b. Okay. Sorry, bitwise or b. 0 or 1 is nothing but it will give you result as 1. 1 or 1 is 1. 0 or 0 is 0. 0 or 0 is 0. So you can get the result here as 0, 0, 1, 1, which is similar to b, right? So c value will be now 3. C value is 3, like this. This is how it is going to produce value of CS3. And let's write a program related to bitwise OR operator. Okay. So first include the necessary header file. In the main function, consider two variables. Okay. Int a is equal to, let us suppose 7 and b is equal to 3. Okay. And c is the resultant variable where I am placing the result. Okay. So c is equal to a or b. Now let's print the result value of c, percentage d, c value. Okay. So let's see how this program is going to be executed and what will be the corresponding output displayed by this particular program. Okay. So again, a is equal to 7 here. You can see it is going to create a memory location and its value is 7. And b is going to have a value called 3. Okay. Now c is equal to a or b. Represent 7 according to 8421 representation. It is 0, 111. Next b, 3. Okay. Value of 3 is represented as 0, 0, 1, 1. Okay. A or b. Okay. So 1 or 1 is going to produce the result as 1. 1 or 1, 1. 1 or 0, 1. 0 or 0, 0. So the corresponding result that is going to be displayed as C value is equal to again This is similar to value of A. Value of A is 7. So it is basically 4 plus 2 plus 1, which is 7. So in the output, it is going to display value of 7, just like this. Now we'll consider bitwise XOR here. Next one is bitwise XOR operator. Bitwise XOR operator is represented like this. Again, this operator is also a binary operator. It means it is also applied between two values or bits. You can see here. Consider bit 1 and bit 2. Okay. Now perform XOR operator, bitwise XOR between two bits like this. Okay. So the possibilities are 0, 0, 0, 1, 1, 0, 1, 1. So according to bitwise XOR operator, when both the bits are opposite to each other, then it is going to produce a value of 1. If both the bits are same, it is going to give you the value of 0. So if the bits are opposite to each other, then you will get to result as 1. Otherwise, you will get result as 0. Yes or no? Like this. Now, let's consider an example here. A is equal to 4 and B is equal to 6. Okay. So we are performing a XOR operator between A and B. Okay. So consider C is equal to A XOR B. Okay. And what is the A value? 4 and B value is 6. So let me represent A value according to 8421 code representation. 4 means 0, 1, 0, 0. B means 6. This is 0, 1, 1, 0. Okay. Now C is equal to A XOR B, which can be represented as 0 XOR 0 is 0. 0 XOR 1 is 1. 1 XOR 1 is 0. 0 XOR 0 is again 1. Okay, 0, right? 0 XOR 0 is 0. 1 XOR 1 is 0. And 0 XOR 1 is 1. 0 XOR 0 is 0. Like this. Okay. So what is the value that is obtained here? Again, 8421 code representation. C value is 2. C value is 2. Just like this. Okay. So now we'll write a program related to this. Okay. So in the main function, consider two variables. A is equal to 10 and B is equal to 12. Now let's perform XOR operation between A and B. Okay. So finally display value of C as the result. Percentage D, C value as result. And what is the corresponding output displayed here? First of all, A value is 10. Yes or no? A is 10, B is 12. Okay, C is equal to A XOR B. Okay, so which means first consider 8421 representation of value of A, which is you can see 1010. Okay, and then B value is 12. 12 means 1100. Now we are performing XOR operation. So C is equal to A XOR B, and you can see whenever both the bits are opposite to each other, in that case you will get result as 1. Okay. In other cases, whenever bits are same, you will get result as 0. So again, according to 8421 representation, you can see C value will become 6. C value is 6. So you can see the output displayed is 6. Okay, like this. Now I'll consider another program related to XOR operator. Okay, which is important. In the main function, I'm considering initial values of A and B. Suppose A is equal to 7 and B is equal to 10. Okay, like this. Now A equal to A XOR B. B is equal to B XOR A. And A is equal to A XOR B. So let's print value of A and B now. Printf %d A comma B. Okay, like this. Now what is value of A and value of B here? Okay, so you can see here A value is equal to 7 and B value is 10. So when you are performing A is equal to A XOR B, first of all represent A according to the 8421 code representation. Okay, so this is 0 1 1 is the corresponding representation of A. Now B can be represented as 10. So 10 is nothing but 1010. Okay, so A XOR B means when 1 and 0 opposite to each other, so 1 and 1. Okay, you can see this is 0. 1 XOR 0 is 1. 0 XOR 1 is 1. Okay, like this. So what is the value of A currently? Because we are performing A is equal to A XOR B. Okay, so this is going to be A value. Okay, A value is now modified to 8 plus 4 plus 1. Okay, what is 8 plus 4 plus 1? Okay, 13, right? So this is going to be 13. Now B is equal to B XOR A. We need to perform XOR operation between B and A. So again consider the updated value of B. Okay, what is the B value currently? 1010, and A value is 13 and it is represented as 1101. Okay, so B XOR A, which means 0 XOR 1. What is 0 XOR 1? 1. 1 XOR 0 is 1. 0 XOR 1 is 1. 1 XOR 1 is 0. Okay. So this is how B value is modified. You can observe B value is clearly 0 1 1 1. Okay. So 0 1 1 1 is nothing but value of 7. Okay. So now B value is 7 here. Later you need to perform A is equal to A XOR B. So when you perform A is equal to A XOR B, okay, A is equal to A XOR B. What is the value of A that you have computed here? A value is 13 currently and B value is updated to 7 as of now. Okay. So you need to consider these values. Since A is equal to 13 and B is equal to 7, now you need to perform A equal to A XOR B. A value is according to 8421 representation. Okay, it is 1101 and B value is 7, which means 0 1 1 1. Now A is equal to A XOR B. So this is going to be A value. Okay. And you can see 1 XOR 1. 1 XOR 1 will be how much? It will be 0. 0 XOR 1 is 1. 1 XOR 1 is again 0. 1 XOR 0 is 1. Okay. So 1 0 1 0 and finally A value will be 10 and B value will be 7. So these are the final values. Okay. You can see A is equal to 10 and B equal to 7 are the final values. And you can observe the initial values of A and 7 are 7 and 10. Whereas in the output, okay, they are A value will become 10 and B value will become 7. It means this is the code for swapping. This is a code for swapping two values without using arithmetic operators, okay, without using temporary variable. So this is completely based on operators which are bitwise. Okay, so we are using bitwise exclusive OR operation and performing this swapping. Okay, so this is about bitwise XOR operator. So these three are done. Now next one is bitwise NOT operation. Okay. So if you observe bitwise NOT operation, first of all, this is a unary operator. Bitwise NOT operator is a unary operator. Okay. So and this bitwise NOT operator is going to convert 0 into 1 and 1 into 0. Okay. So it is just like one's complement, concept of one's complement. Okay. So consider bit 1 and bit 2. Suppose the bit 1 is 0 and not operation. Okay, this is basically we are going to write here. Okay, so consider like this, bit 1 and not of bit 1 directly, or you can also consider b2 is equal to not of bit 1. Okay, so 1 not operation is applied, it will become 0. If you consider bit 1 as 0, when you apply not operation, it will become 1. Okay, like this. So we will consider an example value of a. Okay, consider value of a is 8. Value of a is 8. So how this 8 is represented according to 16-bit format? Okay, how this 8 is represented? You can see 8 is represented using 16-bit like this: 4 zeros and then again 4 zeros, again 4 zeros, and then 1000. This is a representation of value of A, which is 8. Okay. Now performing negation of A. So every occurrence of 0 is converted into 1 and 1 is converted into 0. Okay. You can see 0 is converted into 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. This 1 is converted into 0. Then again 1, 1, 1. So this is a corresponding representation for bitwise NOT operation. Okay. So next one is left shift and right shift operators. Okay. So we'll discuss about left shift operator. And according to this left shift operator, so the general syntax of making use of left shift operator is generally variable is equal to, okay, another variable left shift position. It can be the same variable or another variable. Okay. So it performs a left shift operation on the variable by the specified number of positions. Okay. So let's consider an example here. A is equal to 4. A is equal to 4. Now we are considering B is equal to A left shift by 3 positions. A left shift by 3 positions. So if I represent the same using 8-bit, so we can represent like this. Value is 4. So according to 8421 code, it is represented like this. Okay. Now A left shift 3. It means this must be left shifted by 3 positions. 1, 2, 3. Okay. So the value will become like this: 0, 0, 1, 0, 0, 0, 0, 0. You can see according to 8421 representation, this is 16 and this is 32. Okay. So the value of B will become 32 here when you are performing left shift operation by 3. So what is the equivalent operation for this left shift? So the same action is evaluated like this: B is equal to A into 2 power 3. So whatever position that you are writing, so the same thing is taken in the form of a power. So that is, if this expression you want to write, then this is nothing but variable is equal to variable into 2 power position. 2 power position. Okay. So B is equal to A into 2 power 3. So you can see B is equal to A value. What is value of A? A value is 4. 4 into 2 cube. Okay. So B is equal to, this is 32. Because 2 cube is 8. 4 into 8 is 32. So the same output is produced here also. So multiplying with the 2 power position will give you the same action performed by the left shift operation on the given position. Okay. So we will consider an example for this left shift operation. So in the main function, we are considering a variable like this. int a is equal to 4, okay, and position is equal to 5, okay. So in the printf statement, we are prompting to print %d a left shift position. This is basically an expression that is evaluated and the result will be displayed. Okay, I'm not storing the result in any variable. I'm using directly as an expression. Okay, so you can see here a is equal to 4. A is equal to 4 can be represented according to this 8421 code represented. Okay, so 0100. Okay, now position is equal to 5. Position equal to 5 means how many positions it is going to move? One position, second position, third position, fourth position, and fifth position. Okay, now it will be 1 0 0 and 4 zeros like this. Okay, so you can see a left shift by position is written as 4 left shift by 5. So this is also performed by 4 into 2 power 5. 4 into 2 power 5 is nothing but 4 into 32. So this is going to give you the result as 128. Okay. And even this is also 128 because this is 128, this is 64, and this is 32, this is 16, this is 8, this is 4, 2, 1, like this. So when this bit is on, which means the value is 128, similar to this one. So the output that is going to be displayed here is 128. Okay. So this is about left shift operation. Okay. So next one is a right shift operation. So let's discuss about a right shift operator. Okay. So according to this right shift operator, the general syntax of using this right shift operation is that, again, write a variable equal to variable corresponding value, right shift by position. How many positions you want to move this bit towards right hand side? Okay, that is specified in the position. An example for this is clearly a is equal to a right shift by 2 positions. Okay, so consider a is equal to 8, then a right shift by 2 positions. 8 can be represented in 8-bit representation as 1000. Now you want to move this bit towards right by 2 positions, position 1 and position 2, and you can see the result. All 4 zeros, 0, 0, 1, 0. Okay. So this is clearly representing 2. The value is 2. Okay. Like this. So now you can also clearly understand here this right shift operation is replaced by division operation internally. Okay, so I'll show you here the same thing can also be done like this. Okay, this is nothing but a is equal to a divided by 2 power 2. So which is nothing but a value is 8. 8 divided by 2 power 2. So 8 by 4 will be 2 here. Okay, just like this. And now here we'll see a program related to right shift operator. 32 and position is equal to 4. Okay, so now we are printing the result like this: printf percentage d a right shift position. So when you represent a value as 32, okay, you can see this is 128, 64, 32, 16, 8, 4, 2, 1 for 8-bit representation. Okay, since 32 is the value of a, exactly at 32 bit will be on, in all other position bit will be off. Okay, and perform right shift by 4 positions. So this is one position, second position, third position, and fourth position. So you can see this is going to produce the result like this. And again, according to 8421 representation, value is 2 here. So in the output, it is going to produce value as 2. So the moment you write a right shift by position, this is internally 32 right shift by 4. Okay, and its replacement is division operation, 32 divided by 2 power 4. Okay, and 2 power 4 is 16, so 32 divided by 16 will be 2. So this is the corresponding output produced. So clearly this is about right shift operator. Okay, and also we have some shorthand arithmetic assignment operators, shorthand bitwise operators also available. Okay, so if you consider shorthand arithmetic assignment operators, shorthand assignment operators, okay, we can consider. So examples for the shorthand assignment operators is, suppose a is equal to 10. Okay, a star equal to 3. Okay, so what is the value produced by a? You can see this is nothing but a is equal to a into 3. So a value is 10. 10 into 3, value of a is 30. Okay, this is example 1. Next, similarly, you can also consider another operator like b is equal to 20, b slash is equal to 4. Okay, then what is the value produced by b here? This is evaluated by b is equal to b slash 4, and b is equal to 20 divided by 4, and b value will become 5 finally. Okay, and not only on this arithmetic operators, these shorthand operators are also applicable in bitwise operators especially. So even in bitwise operators, you can see, let us suppose a is equal to 3 and B is equal to 2. Okay. Now we can write A left shift equal to B. So how this is going to be evaluated? So this is written as A is equal to A left shift B. Okay. So which is nothing but A is equal to 3 left shift by 2 positions. Okay. So value of 3, again you can see here according to 8421 representation. Okay. First 4 bits will be zeros, and to represent 3, 0 0 1 1. Okay. Now left shift by 2 positions, 1 2. Even here this is also 1 2. Okay. Or simply you can also say 3 left shift 2 is nothing but 3 into 2 power 2. Okay. So A value finally becomes 12, just like this. Okay. So similarly, you can also apply this operator, okay, shorthand operator for bitwise AND also. For example, A is equal to 5. Okay. Now A AND equal to 2. Okay. What is the corresponding result obtained for A? So you can see here A is equal to A and 2. So let's perform this action. A is equal to A and 2. Value of A is according to 8421 representation 0 1 0 1. Okay. And 2. 2 can be represented as 0 0 1 0. And we are performing AND operation. So A value will be 1 and 0 will be 0, 0 and 1 will be 0, 1 and 0 will be 0, 0 and 0 will be 0. So like this, value of A will become 0 here. Okay, like this. So these are some examples of the shorthand arithmetic assignment operators and shorthand bitwise operators as well. Okay.